Section 11.2, Surface Areas of Prisms and Cylinders. A prism is a polyhedron with exactly two congruent parallel faces. Those two congruent parallel faces are called the bases. You name the prism by the shape of the base. In our diagram, the base is identified as the top section of this prism and also the bottom section of this prism. They are congruent and parallel, and they also are in the shape of a triangle. Therefore, this is called a triangular prism. The other faces of my prism are the lateral faces. Here, our lateral faces are rectangles. The intersection of our lateral faces are known as the lateral edges. An altitude in a prism is a perpendicular segment that joins the planes of the two bases. In our first diagram, our bases are in the shape of a pentagon. In other words, they are 5 edges. Therefore, this is a pentagonal prism. Our two bases in this diagram are the top and the bottom. The lateral faces are the rectangles that are encircling our prism. The segment that is perpendicular from the base to the base is a lateral edge, and it's perpendicular on the interior of our diagram. This is known as the altitude. The altitude is the height of our prism. In this diagram, this is a right prism. In other words, the segment is perpendicular to the base on the interior of our diagram. To the right, this is called an oblique prism. In this situation, our prism is skewed in some direction. Therefore, our altitude is on the exterior of our diagram. In both cases, the altitude is defined as the height of our prism. To further clarify, a right prism are when lateral faces are rectangles and the lateral edges are altitudes. Oblique prisms are not right prisms in the sense that the lateral edges are not altitudes and the prism is skewed. On the left side, we have two diagrams. In this case, these are right prism, where our lateral edges are perpendicular to the base, and those faces are perpendicular to the base. On the right diagrams, these are oblique prisms. In this case, our rectangular faces are not perpendicular to the base, and our altitude would be on the exterior of our prism. But in both cases, those altitudes would be the height of the prism. Prior to solving solutions about lateral area and surface area, remember that all solutions must be in terms of square units, such as square inches, square millimeters, square feet. So make sure when you have your solutions that they are all termed in units of square units. The definition of the lateral area of a prism is the sum of the areas of the lateral faces. Therefore, this does not include the area of the bases. Here, our lateral area is equal to the area of rectangle A, B, C, F, area of rectangle F, C, D, E, and the area of rectangle A, B, D, E. The surface area of a prism. This is the surface area of the lateral area and the area of the two bases. Therefore, in this diagram, I have the surface area that is equal to the lateral area, which we defined on the previous page, and the area of the two bases, which are triangle A, F, E, and triangle B, C, D. Theorem 11.1 states the lateral and surface area of a prism is the lateral area of a right prism is the product of the perimeter of the base and the height. Here our formula for lateral area is equal to P, which in our diagram equals the perimeter of the base. In this instance, it is a rectangular base. And our formula for perimeter in a rectangular base is 2 times the length plus 2 times the width. In other words, the distance around our base. H, as defined previously, is the altitude of our prism. The surface area of a ray prism is the sum of the lateral area and the areas of the two bases. Here, we have B defined as the area of the base, which we know is the length times the width. Therefore, in our formula for surface area, we determine the lateral area plus the area of the base, and we take that times 2 because we have two bases, and then we find their sum. In this example, they want us to use a net to find the surface area of the figure. Here I'm given a prism with a dimensions of 6, 8, and 12. Our front lateral face has the dimensions of 8 by 12 for the front and the back. The left and right lateral faces have the dimensions of 6 by 12, and our bases have the dimensions of 6 by 8. What I need to do is to use my net, which is a representation of each polygon of my lateral faces and my bases. And that net is a representation of the figure that is unfolded. In other words, here is my front and back lateral face. The dimensions of my front and back lateral face are 8 by 12. And I have two of those rectangles by the dimensions of 8 by 12. The left and right lateral face has the dimensions of 6 by 12. And again, I have two rectangles with that dimension. I have a base with the dimensions of 6 by 8. And again, I have two of those figures with that dimensions. To find the lateral surface area, I need to find the sum of my four rectangles. Two with the dimensions of 8 by 12. Remember, area of a rectangle is length times width, or base times height. I have 2 with that dimension, plus 2 times 6 times 12, because I have two lateral faces with that dimension. When I simplify, I'm going to get 8 times 12, which is 96. 96 times 2 is 192. Plus 6 times 12 is 72 times 2 is 144. Therefore, my lateral area is 336. My area of my bases equals the dimensions of my base, which are 6 times 8. That's my area. But I have two of them, so I'll multiply by 2. So that's going to give me 6 times 8 is 48 times 2 is 96. So my surface area is going to equal 336 plus 96. And when I find that sum, I get 432. In this figure, again, I want to use a net to find the surface area of my prism. Here, my prism is a triangular prism because my bases are in the shape of a right triangle. I'm given the dimensions of 3 by 4 by 10. I can determine the side of my hypotenuse of my right triangle because I know this is a triple, which is a 3, 4, therefore this is a 5. Or I could use the Pythagorean theorem. I'm going to use a net to help us find the surface area of my prism. I know my net is the unfolded representation of my prism in the shape of the polygons. So here, my polygons are in the shape of 3 by 10. The back lateral face is going to be 5 by 10. And the right lateral face is going to be 4 by 10. So to find the lateral area, I find the area of each of those rectangles. 3 by 10, 5 by 10, and 4 by 10. Simplifying, 30 plus 50 plus 40. Finding the sum, I'm going to get 120 for my lateral area. Now I need to find the area of my bases. To do this, I need to determine the height of my triangle, or the altitude of my triangle. I'm given a right triangle, and I know the dimensions are 3 by 4 by 5. I know that the area of a triangle is equal to 1/2 the base times the height. The height is any perpendicular segment from the vertice. Therefore, all I need to do is substitute in 1/2 times the base, which is 4, times the height, which is 3. If this wasn't a right triangle, I'd have a lot more difficulty because I'd have to find an altitude from that vertice to the base. And that would be very difficult. But since this is a right triangle, each of these legs are an altitude, so it doesn't matter which one I use. Also, this makes it easy because I'm given two triangles. Therefore, I'm going to have to multiply this by 2. And when I do that, I'm going to get just 4 times 3. So 4 times 3 is 12. That is the area of my 2 triangles. Or in other words, each triangle would have been 6, which is 4 times 3, which is 12, divided by 2, which is 6. Multiplying by 2 because of 2 triangles gives me 12. Now, the surface area is going to equal 120 plus 12, which equals 132. In this example, they want us to use the formulas to find the lateral and surface area of each prism. Then round your answer to the nearest whole number. Here we have a triangular prism. It's the same shape as we had in the previous example. Therefore, I know the hypotenuse. Here I had 3, 4. I know is 5 by the triple or the Pythagorean theorem. It is much easier to use our lateral area formula to determine that area. Our lateral area is equal to the perimeter of the base times the height, which is our altitude. The perimeter of our base is the distance around the object. I just add up the lengths of the sides. Therefore, that is 3 plus 4 plus 5. And multiply that times the height, which is 10. Simplifying, I'm going to get 3 plus 4 is 7 plus 5, which is 12, times 10. And here I get 120 for the lateral area. Again, to find the surface area, I need to find the lateral area, which I did, and then add that to the area of my bases. The area of my base is determined as we have on the previous page, which is, in this situation, area equals 1/2 the base times the height. And in this situation, I'm going to multiply by 2 because I have 2 bases. Therefore, the 1/2 and the 2 cancel out, and I get the base, which is 3, times the height, which is 4. Therefore, my area of bases is 12. Finding that sum, I'm going to get 120 plus 12, which is 132. Again, in this example, I want to find the lateral and surface area of my triangular prism. To begin with, we will find the lateral area. That is the perimeter of the bases times the height of the prism itself. The perimeter of my bases are 5 plus 5 plus 6, and the height of my prism is 8. And when I calculate, I'm going to get 128 units squared. Now what I have to do is find the area of my bases. Of course, the area of my base is a triangle, which is 1/2 the base times the height, and I have 2 bases. We know when I substitute into this formula, I'm going to have 1/2. The base is 6. I need to find the height of my triangle. To do that, I know that this triangle is an isosceles triangle. Therefore, I can get these 2 triangles congruent. I know that because I already have 2 sides congruent. I already have 2 angles congruent by this altitude dropping to the base of my triangle, which makes 2 right angles. Therefore, they are congruent. And by the isosceles triangle theorem, I know that these 2 angles are congruent. So I know that these 2 triangles are congruent by angle, angle, side, or angle, angle, side. That will divide this segment into congruent segments. So I know that this is 3. Now I have a Pythagorean triple, 3, 4, 5. Now I know the height of my triangle, which is 4. And of course I have 2 bases, so I multiply by 2. And when I finish, I get 24 units squared. Now, to calculate the area of the entire prism, I'm going to take the lateral area plus the area of the bases, and when I do, I get 152 units squared. On this example, they want me to determine just the lateral area and then round to the nearest whole number. Here I'm given a regular pentagon. This is a pentagonal prism. And remember, regular pentagon means that all segments of my pentagon are congruent. Therefore, that is 7, 7, 7, 7, and 7. My altitude and height is 12. Remember, lateral area equals perimeter of my base times the height. Here the perimeter of the base is going to be 7 plus 7 plus 7 plus 7 plus 7 times my height, which is 12. Or 5 times 7, which gives me 35 times 12. Simplifying, 35 times 12 is 420. They want to continue with this example. They want to use the lateral area on the previous page and determine the surface area of that same figure. We already have the lateral area to equal 420. The surface area is the lateral area plus the area of the two bases. To determine the area of a regular pentagon, we need to find half the apothem of the perimeter. An apothem is a segment from the center of our polygon that is perpendicular to a side. Therefore, I have a right triangle. I already know that I can make these two triangles congruent. Therefore, that segment bisects the side of the polygon. Therefore, this is 3.5. I also know that at the center, I have a circle. That is 360 degrees. I know that these are 5 congruent triangles inside of my polygon. Therefore, 360 divided by 5 gives me the measure of this angle to be 72 degrees. As a matter of fact, each angle is 72 degrees. And when this bisects that angle, I know that this is 36 degrees. Therefore, by the triangle sum theorem, that is 54 degrees. Now what I do is use the tangent of 54 equals x, which is the opposite, over adjacent, which I know is 3.5. Therefore, when I solve for x by multiplying by 3.5 on both sides and then entering in my calculator, I get x equal to 4.8. Now, what I do is substitute that into my formula. 1/2, the apothem, 4.8. And P is the perimeter. And 5 times 7 is 35. And when I substitute in, I get a value that is equal to 84 for the area of this regular pentagon. Now, for the surface area, I take the lateral area, which I know is 420, plus 2, because I have two bases, times 84. That gives me, when I simplify, 420 plus 2 times 84 is 168. And when I combine 420 and 168, I'm going to get 588.